We are going to bring up Steffen Bornemann. Steffen holds a PhD in polymer chemistry. After studying chemistry at Martin Luther University in Halle-Wittenberg, he worked in different positions for a global producer of hygiene and technical nonwovens. Since 2009, he's employed at a Polymeric Wolfen, a German company producing special polymeric films, and currently he's responsible for research, development, and quality control. He's involved in several publications and patents in polymer science and applications. So thank you for being here with us today and sharing your knowledge. So if we could give a warm welcome to Steffen. Thank you.
Julie, thank you very much for the kind introduction. Yes, please go on with the presentation. Thank you. Here we are. Yeah, good morning, everybody. It's still quite early. The title was already given by Julia, so I want to talk about some, let me say, out of these standards, as we have heard now from Warren. We would like to test different interlayers under conditions a little bit out of the standards or beyond standards, let's say like this. This work is a cooperation of our team at R&D at Folienwerk. Two of us are here. We have also a booth on the show. If you want to discuss something further, we are there the whole time. Okay, short overview. I will give a short introduction into the company. I will give a few words about motivation, and today we have selected 2 case studies to show differences in interlayer and laminated safety glasses under certain climate conditions. Today I would like to talk about climate conditions hot and humid, and we are in Finland, cold climate. Folienwerk Wolfen is a company family-owned in Germany. We are located in Saxony-Anhalt. It's 1 hour south of Berlin, for all of you who know a little bit about Germany. We make a turnover of around about 40 million euro a year. There are 140 employees working in continuous shift operation. We are able to produce up to 20,000 tons of film, polymeric film, a year. We have an own R&D department in-house and also internal quality control. It is our business for some of our products to trace back everything to a single vendor batch, and it is our philosophy for more than 30 years now to produce films or polymeric materials for niche applications for the needs of our customers. I'm quite sure that you all have contact to our products, although you don't know about us, about our company. It all started with packaging. 30 years ago, we were beginning to produce films for food packaging. These films are made of polyester. Yesterday, in one of the keynotes, we heard about recycling, that it is coming into glass industry now. In plastics industry, we are working in recycling for 20, 30 years already. We can offer films with recycled content up to 100%, and this is more and more standard. You heard about the Green Deal from the EU yesterday. This is also what is in our business and what's coming into glass industry too now. Such films are used for food packaging, as I said, or whenever you want to show and protect a product inside the packaging, then you are working with products like this of polyester. We also produce special films for medical device. When you're going into hospital, you will find blue or green boxes. The films for this are made from us, especially in Europe. If you look into your pocket, then I'm quite sure we will find credit card, we will find passports, we will find ID cards. The films for this worldwide can come from us. And last but not least, today I would like to talk about lamination of glass, safety glass especially. For such products, we have some brands on the market. Our trade names are EveGuard and EveGuard MPE. From this, let's go into what I would like to talk about today. In contact with our customers, we always will be faced with questions like this. We have different climate conditions worldwide. We heard this also yesterday in the keynote presentation. and we're serving products. We are using products for buildings and other things made of more or less the same material, same construction. And the question is it worth to use different materials, or what is the behavior of different interlayers in laminated safety glass under certain conditions? You can see two examples here. Okay. On the left side, you can see a building in Qatar, where we have, of course, a hot climate. We have conditions where we have to consider temperature, of course. You see all around some balustrades. This is also trendy, let's say like this. We see it more and more. If you go outside Nokia Arena, you can see also some balustrades with open edges. This is more and more in use now. Compared to this, on the right side, you can see a gate made of a laminated safety glass. And you see from the picture the climate is totally different. We have cold climate, we have snow, and the material has to behave, of course. And we can increase the level of climate one more. If we have a look into a pool in some areas, then we have humidity inside the building. And if we look at the roof, it is made of glass. Then we also have the combination of in and outside. Inside humidity, temperature, outside UV radiation too. We have to consider this. We also can make products with the combination of glass and electricity, as you can see here. These paints are used for a road construction or walkway, and you can see there is some illumination with LED lights inside. And it has to work under conditions where we have snow, where we have Arctic climate, let's say like this. There are some, if you have a look on the world, there are some diagrams that can show the differences, of course. You can see here temperature, wind speed, and rainfall. For comparison, we start always with Berlin. We are Germans, of course. As a reference, in Berlin we have, let me say, moderate climate. You see temperatures here in Fahrenheit, okay. From winter time, it's 30 to 40 Fahrenheit, means +5 or 0 degrees C, something like this. In summer, moderate, 25 degrees C or 60 to 80 Fahrenheit. If you compare it with Tampere, I was surprised to see, but the summer is more or less the same. You see it if you go outside. But winter time, of course, it's colder here, right? And we will find, the further north we go, we will find some areas where the temperature's going down and down, of course. Compared to this, if you have a look into other regions, Abu Dhabi, for instance, Miami, then we have temperatures always above 50 Fahrenheit, 30 degrees C, something like this, up to more than 100 Fahrenheit. And this in combination with wind and rainfall. You see the differences. Again, Tampere is a good example, with no wind at all, surprisingly, more or less. And compared to Miami, we all know hurricane season there, a lot of wind, in combination with heavy rainfall. You can see from this that the climate conditions are totally different. And when we want to make laminated safety glasses for these different climates, then we have different materials on hand. Warren was already talking about some materials, of course. There is a definition of the materials. We can decide between thermoplastic materials and duroplastic elastomeric interlayer materials. Thermoplastic materials, or in thermoplastic materials, the material properties are always related to the thermal behavior of the polymer. As a polymer chemist, we are talking about glass transition temperature and melting point. Examples for this, PVB and also ionomer, we had already. And compared to this, duroplastic elastomeric materials will change its properties during the lamination process. If you buy the materials, they behave like thermoplastic with a certain elasticity. If we put it into a laminator or autoclave, making laminated safety glasses, we achieve temperatures above 100 degrees C. This film material will cross-link. Cross-linking means you have the polymer chains, and we are producing some links between the polymer chains to make a three-dimensional cross-linking. And this leads to different material properties. The film behaves different before and after lamination, means we are making the film a little bit more stiffer, but still remaining flexibility. Example for this is ethylene vinyl acetate copolymer, also known as EVA. And now I want to show you some case studies. As I said, we're talking about 2 case studies today. Let's start with climate hot and humid. Yesterday we had a nice workshop with Julia about some standards. I'm going back to this, of course, but we will go a little bit beyond. If you want to make laminated safety glasses and you want to test weathering conditions, then you go to some standards. You're using weathering standards like ASTM standard here. This is typically done in a way that you have 4 specimens, for instance. You put 2 of them into a weathering machine where you have temperature, UV radiation, humidity, and then after a certain time you take out the samples and check how they look like. You can see it here as a series of photos from material like this. In this case, okay, we have seen some delamination effects already after 500 hours, maybe due to some edge problems during cutting. And then you can see how it was going on with time. You can have some good results, some as you can see on the right side, or you can also find samples where you have delamination effects. For analysis, we are using optical methods to measure the properties of the laminated safety glasses. We measure light transmission, we measure color, we measure the change of the color, of course, and we also measure haze. You can see here some examples. On the picture you can see the effect of yellowing, means there happens something with the interlayer inside, and this leads to a change of the color. And you can see this typically, the material becomes more yellow or brownish. You can see the effect here. We can measure the color. You can see again 4 curves, 2 for the reference samples, and the red and the blue for the samples which were weathered. And you can see the effect here. You see there is a change of the B value in color for the 2 samples of this series. The same happens with haze, or can happen with haze. You see here the change of haze over time. You see that there was, again, the blue and the red line, and haze started to increase after a certain time. The first sample after 1,000 or 2,000 hours, the second after 3,000 hours. This all comes to a conclusion like this. We have taken different materials here. We have a series of different materials as interlayers. A number of these were made of EVA, and for reference we were also working with PVB and ionomer. As I said, we prolonged the test beyond the typical standard. We went up to 6,000 hours in this case. You see from the legend, as long as everything is green, it is okay. It is within the tolerances, allowed tolerances. There is no change of the specimen. If it becomes then yellow, okay, there was something, delamination, color change, whatever. And if it turns to orange, then there was a failure, a total failure, a major failure in the system. And we compared this together. This work was done together with Fraunhofer Institute in Germany and with the University of Magdeburg. And this project was funded by the European Union. What does this mean at the end? If we see color change or delamination, there happens something with the interlayer, with the polymeric material. We talk about degradation, means the polymer chains will break, and this leads to less strength, and this can be a risk for safety applications. The same with delamination. Delamination, the effect is shown on the picture on the left side. You know this, I'm quite sure you have seen this on open edges, and you know when this happens, then you're losing the contact between the glass and the polymer. And this can lead, again, to a safety risk. If you talk about balustrades with open edges, this can end as a disaster. Okay, second case study. Let's go to cold climate. At first, again, Vaughan was already talking about the effect of interlayer film in safety glass. You can see it on the video now. the function of the interlayer. You see the glass is breaking, in this case with a ball drop, and you see the glass is falling into pieces, but sticking to the interlayer. The interlayer has the function to absorb energy, and the second thing, to reduce the amount of glass splinters. And this leads to a higher safety level. In this case, we have done, for this case study, we have done a ball drop test. You see the result is quite easy. You take a ball, and if the ball is still there after the ball drop test, the test is passed successfully. If not, it's a failure. There are a lot of standards again. In this case, we were working with a European standard, with a German one. You see on the right side the machinery for this. There will be a glass, 500 by 500 millimeter, a laminated safety glass, placed into this frame. We have a magnetic holder for the ball, for the steel ball, and then we put it to a certain drop height and let it fall down and see what happens. The results will be shown now in a short video. In every case, we have done 5 tests per material, and we were looking for different temperatures, in this case at cold temperatures. This test was done together with Friedmann Kirchner, an institute in Germany. Let's start with 0 degrees C. Drop height in this case, 4.5 meter. The film used was an EVA film. Okay, ball is falling down, not falling through, passed. The same with PVB, same drop height, same thickness of glass and interlayer, of course. Let's see, it was okay. Then we have special interlayers where we improve the strength of it. In this case, we have EVA and we call it MPE. Drop height in this case is 6 meter. 6 meter for stiffer material because of the comparison with ionomer. At 0 degrees C, everything is fine so far. Now let's have a look at -40. Again, we start with EVA, same drop height as before. First difference, the glass is white now because it comes out of the fridge, but everything else is the same. Then we do it with PVB one more time. And in this case, we can see failure. Then again, we go up to 6 meter, EVA and special interlayer combination. Good result again. And finally, ionomer one more time at -40 degrees C, 6 meter. Fail. What does this mean? I was talking in the beginning about different materials. We were talking about thermoplastic interlayers. And we all know when we come down in temperature, then we are in the region of glass transition temperature or below glass transition temperature. And this means a plastic becomes brittle. And in case of thermoplastic interlayer films, we see that brittleness can lead to a failure in some tests, in this case, ball drop test. Compared to this, duroplastic elastomeric material remains flexible also during this test, and you have seen from the video the difference. Again, this could lead to some failure in the product and to risk of loss of safety properties. Ladies and gentlemen, at this stage, I'm close to the finishing of my presentation. I have a short summary. It was the task today to show you some results on the contribution of interlayer, of different interlayer, on the performance of laminated safety glass. And we have chosen 2 case studies. We were talking about hot and humid environment as well as cold climate. You have seen that the selection of the right interlayer will have an impact on the properties of your laminated safety glass. If you're a glass producer or processor, then of course it's now your turn because you have to make your choice. You have to ask your suppliers and you have to discuss it for your certain projects in certain climate regions to find out what the right combination for your choice would be. At this stage, I can say thank you very much for your attendance and I'm here for your questions.